Okay, this is a video for MAC1105 section 2.5, and in this video we're going to be looking at various transformations for graphs. And as we begin to look at how to perform the transformations, I would like to give a review of the shapes that we've been working with throughout chapter 2. Also in chapter 1 these shapes are introduced. So in the first graph, what you see is what's called a constant function. This is actually a horizontal line, and it is given by f of x equal to some constant. Remember, f of x is the same thing as y. So this could also be written as y is equal to the constant that you're seeing this line go through is 1.5. So this could be written as f of x equal to 1.5 or y equal to 1.5. Slanted lines, in other words non-vertical lines, that this one is going right through the origin, and the equation for such a line would be f of x is equal to 1x. This V shape, that is caused when there is an absolute value bar around the x. That will give you this V shape. That's the absolute value graph. One that we've been working with quite a bit throughout the chapters is the parabolic shape, and that's obtained when there is a square on the x. The parabola can either open up or it can open down if there's a negative out here. Next is the square root shape, and the square root shape kind of looks like half of a sideways parabola. When there is only a positive out in front of that square root, it'll give you the upper half. And if there's a negative, then that portion would be coming down here rather than up here. The cubic graph. Whenever you have a cube on that's going to give you this nice little wave going right through the origin, unless there's shifts on it, but then that's what this section's about, with one portion in quadrant 1 and then curling down in quadrant 3. If there was a negative, there would be part of it here and then curling down in quadrant 4. Then when you take this graph and turn it on its side, you get what's called it looks like part of this, like part of a sideways parabola, and then one in the opposite direction in quadrants 1 and 3. With a negative, it would just be this graph, and it would be in quadrants 2 and 4 if there was a negative out there. So just basic shapes that will be popping up over and over again. Very good if you would memorize the key shapes, because you're going to be expected to do many of these without your calculator, and knowing how to connect the points that you're creating, because we're going to work through creating points for the parent graph, transforming the points, and then getting the transformed graph. And that's when it would be important for you to know the shape so that you don't connect the points in some kind of weird way. So now we start to look at the shifts that we're going to be carrying out in this section. Notice that this black graph that you see right here, that is the parent graph, and they're trying to show you a picture of a graph that has been shifted vertically up, and where the number would be if you were going to do something where there was a vertical shift. A vertical shift can look something like this. Let's say that the first graph was just a line like that. And all of a sudden in the next graph, let's say that they give you a different function, and that they say for this function, you're going to take that parent graph and you're going to do this to it. When the number that's either being added or subtracted is not inside of a parenthesis with the x, inside of some kind of grouping symbols, it doesn't have to be parentheses, but it's just a free and loose term. This is what's known as a vertical shift, and it would be a +5 vertical shift, and that would mean that it would go 5 units up. Vertical shifts behave exactly the way the sign indicates that it would shift, whereas horizontal shifts don't do that. Let's say that they gave you some other function that was the parent graph, but then with a -5. That would indicate a vertical shift of -5. That would mean it would be going, compared to the parent graph, it would be moving 5 units down. So point being, when you're doing a vertical shift, number one, that number will not be in any kind of grouping symbols with the X. It'll be a free, loose term, and you will not switch the sign. You will act upon your vertical shift using the same sign that you see in the equation. If it's a +5, you'll go 5 units up. If it's a -5, you'll go 5 units down, or whatever the constant happens to be. The point being, go up if there's a plus, minus if it's down if it's a minus sign. Okay, moving to a problem where we can actually sink our teeth into that vertical shift and what it means with respect to how to transform the points and how to act them out within the graph. So here's a picture of two absolute value graphs where a vertical shift has actually happened. This is the parent graph, and they're giving you 3 points. You know, once you get further into the section, you'll be creating the points yourself for the parent graph as well as the transformed graph. But let's just take it one step at a time. Here you've been given the points. They've selected just 3 points, 3 key points on the graph, -4, 4, which is right here, 0, 0, and also 4, 4. So these are points on the original parent graph. Then they've asked you, and that's called f of x, and then they're talking about another graph, which will be the transformed graph. They're asking you to take that shape, that's why you see the absolute value of x again, and do this to that. Do this to the parent graph. So because this number is not inside where the x is, inside these grouping symbols that give it the shape, this is what's known as a vertical shift, and you will act upon that vertical shift by using the same exact sign. That is always true of vertical shifts. Use the same exact sign as you try to transform the points as you see in this equation. So for instance, if these were the original points on the parent graph, -4, 4, 0, 0, and 4, 4, all we're going to do is use this -4 and try to understand and get a concept that when you're doing a vertical shift, you're moving either up or down depending on the vertical shift you've been given. Here it's a -4, so we're going to be moving down. When you move up or down, up and down, just like the y-axis goes up and down, that has to do with y coordinates. So when you do a vertical shift, you're going to be acting upon your y's, your y values. Horizontal shifts are moves that act upon the x coordinate, but when you're doing a vertical shift, you're affecting your y coordinate. So that being said, these original points, we're going to subtract 4 each time, but we're only going to do it to the y's, and we're going to leave the x's alone. So notice that for each of these y values, 4 has been subtracted to create these brand new points called the transformed points on the g of x function. 4 take away 4, 0. 0 take away 4, -4. 4 take away 4, 0. Yet all the x's have stayed the same. -4, 0, and 4. So now we have our original set of points, which you see already graphed for you. And then now you can also maybe understand where these points came from. We just took these points, transformed the y coordinate, came up with -4, 0. Which is on this graph that you see right here, -4, 0. This new transform point, 0, -4, is now the new vertex, and 4, 0 is now another transformed point, all obtained by subtracting 4 from the y coordinates on the original points. Okay, and that's what we're going to be doing mostly throughout this whole section, learning how to read the commands that have been given to us, whether that command be to do a vertical shift, a horizontal shift, a horizontal shrinking, a reflection. There's various transformations that we're going to review all of them within this section. Okay, now let's move to horizontal shifts and see if you can get the distinct differences between a vertical shift, which we just went over in the previous example, and a horizontal shift. In a horizontal shift, you're shifting either to the right or to the left. So for instance, if the original function was f of x, and all of a sudden you see that they're trying to get you to carry out this kind of transformation, which is, let's make this a little bit bigger. They're trying to get you to do a horizontal shift. You'll see that the number will be inside of some kind of grouping symbols, either parentheses or the symbol that creates the shape for the particular graph that you're trying to draw. So if you see a plus sign with horizontal shifts, a very big difference is that with a horizontal shift, you do not use the sign presented in the function. So if you see positive C, you're going to use negative C. You must switch the signs when you're doing a horizontal shift. Switch the sign on that C value. And that C value just stands for some constant, any kind of constant that they can be given. Once you switch the sign, then you are going to act upon the X coordinates. Horizontal shifts mean you're moving left and right, and movement in a left or right direction concerns the X coordinates. So act upon your X coordinate when you're trying to perform a horizontal shift. Don't forget to switch the sign. Okay, again in this picture, so this was the original picture. There was a positive there, so instead of moving in the positive direction, it moved in the negative direction because this is the new function. Likewise over here, this was the original function in black, and then because there was a negative C here, you're really going to do a horizontal shift of positive C. We always switch the signs and then act upon the X coordinate with that new, after you've switched the sign. I'm just going to abbreviate that. So notice that this is a negative. Maybe you were expecting the new graph to move in a negative direction, where in reality it has moved in the opposite direction. So that is the main difference between vertical shift and horizontal shift, is that you must switch the sign. And of course, you're not acting on the Y coordinate as you are with a vertical shift. You're acting on the X coordinate, which that'll be pretty easy to remember because the horizontal shifting number will always be hanging around with the X inside of a grouping symbol, whether those be parentheses or the actual symbol that creates the shape of the graph. Okay, looking at a real live problem, we look at the fact that in this problem, the parent graph is just square root of X, whereas in the new transformed function, it's going to be square root of X plus 5. Notice that instead of the 5 being out here, it is inside the symbol that actually creates this shape. Those are considered like grouping symbols. So it is hanging around with the X instead of the 5 being outside on the outside of the radical. So this is a horizontal shift, and we have to remember that even though it's presented in the new function as a positive 5, we really need to switch it and do a horizontal shift of negative 5. So notice that we're really going to be subtracting 5, and we're going to be doing it on the X's. So let's take a look at all our X values. These were the X values in the original point. They have been chosen for you once again. This is the parent graph. The values that were chosen were just some key points on the graph, not all the points. You don't need that many. 0, 0 was chosen, 1, 1 was chosen, and 4, 2 was chosen. And on each of those points, we're doing a horizontal shift of negative 5, and we're doing it on the X's. All horizontal shifts are performed on the X's. So notice that it was 0, take away 5. And we're using minus 5 on each of these X coordinates. So 1 take away 5 resulted in negative 4. 4 take away 5 resulted in negative 1. Yet the Y coordinates have stayed the same. We were only working on the X's, and this is what we were doing. So that's still a 0, that's still a 1, that's still a 2. So now plotting these new points and making sure to preserve this same shape. We are getting, let's see, negative 5, 0 right there. Then we also plotted negative 4, 1, and we also plotted negative 1, 2, preserving the same shape as the original. And in doing so, we forced this graph to move 5 units to the left and acted out what's called a horizontal shift. Okay, so in the next video, what I'm going to be demonstrating is how to take both of those shifts and perform both of them at the same time in one function.